Hi, we're starting Chapter 8, which is inverses and radicals. Today we're doing 8.1, composition of functions. If you're in one of my classes, I probably passed out this sheet in class. If not, you could get to it through Moodle. If you're not, you're still welcome to watch the notes. You maybe will have to do a little bit more writing. It's just a writing-intensive section, these next three, so typed up some of the stuff. Going back a while, we were talking about Euler's notation earlier this year, where we had f of x equals some equation, and we did f of 5 or f of 3x or something. So that's my example here. I have this beastly looking equation for f of x, and we have f of 5. What that means then is you put a 5 in place of x. And if you try to line stuff up, I didn't do a great job here, but if you notice f of 5, 5 is in the spot of x, so then wherever you have an x, you replace the variable, the x in this case, with the 5. So you have 25 minus 10, 15, plus 3, so f of 5 then is going to be 18. I found that people are pretty good with that. If I do something like this, if I throw them something where there's a variable in there as well, it really messes with people's heads. It's the same exact thing though, that you take whatever is inside the parentheses and you replace x with it. Actually, I'm going to write that up at the top. So that's key. So you replace, I probably should say the variable, yeah, why not? Replace the variable with whatever is in the parentheses. So it doesn't matter that there's an x here in the parentheses and that there's an x up here. You just replace these x's with what's in the parentheses. So instead of x squared, I now have x plus 2. All of that replaces my x in my original equation. So all that is squared. Then I have minus 2x here, so it's whatever's in the parentheses, x plus 2, replaces that x up above, and now I have a plus 3. Alright, here we get to FOIL. I'm going to do it the long way just so I don't lose people, but I'm hoping a lot of people will just jump right down to what I write right there. But x plus 2 quantity squared, it's not x squared plus 4, it's all of this times itself. So that's where we'd have to FOIL. So we get first times first, so x times x is x squared. Then we do outsides, a positive x times a positive 2 gives me plus 2x. Then we do the insides, a positive 2 times a positive 1x, another plus 2x. Then we do the last, the positive 2 times positive 2 is a positive 4. And hopefully a lot of people just from here jumped right down to here, like I was saying, that whenever you FOIL, you can combine the outside and inside terms, those two right there, gives me a plus 4x plus 4. Okay, so my first thing, x squared quantity x plus 2 quantity squared gives me this. Now here, it's easiest, I think, if you look at this minus 2, if you distribute that negative when you distribute the 2. So kind of look at this as though it's plus a negative 2. And I'm just going to jump right down here to this step and say, alright, so I have a negative 2 times x gives me minus 2x. Here we have a negative 2 times a positive 2 for a minus 4. And then last we can just copy down this plus 3. Alright, most of the problems aren't this bad. If you can do this, you can do any of them. Now I'm going to underline the parts as I use them. So I've collect like terms is the last step. So I have 1x squared. So that's x squared. I have positive 4x here minus 2x. So that's going to give me a total of positive 2x's. I had positive 4, took 2 away. Then I had a plus 4 and a minus 4. Those cancel. And a plus 3. Gives me a plus 3. So that'd be the answer there. And most of the time it's not going to be quite that brutal. So something like this is maybe what I should have stuck with. So same thing, but you'll see the math works out a lot better. Last one, just a different variable, but we're going to take our original equation here. I'll try to draw some attention to it. So x squared minus 2x plus 3. And now wherever we see an x, we're going to replace it with 3n. So we'd have 3n, all of that squared, minus 2, instead of the x we replace it with 3n, so 2 times 3n, and then my plus 3. And you'll see this is way shorter. When we have 3 times n all squared, that becomes 3 squared n squared, so 9n squared. Then we have this minus 2 times a 3n gives me a minus 6n. Then we have a plus 3. So that's our final answer. I'll write it in the blank here. So 9n squared minus 6n plus 3. Way easier when we don't have a plus like this x plus 2. Alright, so enough review. Let's hit the new stuff. Composition of functions means that where before we always just had like a f of x or a g of x or something like that, now we're going to have a f of g of x. That instead of doing the problem once, you kind of do the problem twice within one problem. So composition of functions, kind of like composing music, you're putting different parts together. We have by f of g of x, or the composition of f and g, we mean the following. That anytime you have a whole bunch of parentheses, we always start on the inside. So with this f of g of x here, we start with that g of x. You figure out, well, what does g of x equal? And once you figure that out, say we say that that equals 5, when we get the answer, now we'd have f of 5. That's what I'm trying to say here. So then evaluate f of whatever the g of x equals. In other words, f of the answer to g of x. So have an example here. So suppose f of x is x plus 5 and g of x is x squared. So now we'd start out with this g of 3, and maybe I'll color code things a little bit. So we have find g of 3. So we take the 3 and we have to put it in our g function, not our f function, because it's g of 3. So 3 squared then gives me 9. So then I'd have that inside the parentheses equals 9. That's where this f of 9 comes from. So then finding f of 9, well, because it's f of 9, we'd look at this f function. And the 9 is in the parentheses, so it replaces my variable. So 9 plus 5 then would give me 14. So f of g of 3 then equals just 14. So just like with any parentheses, you work from the inside out. And in order, given x, find g of x, use this to find f of g of x. All right, so I want to do that with a few more examples. I have one more on this page. So like before, we start with the g of x because that's on the inside. And our g function was x squared. So this here then becomes negative 1 squared. It would be amiss if I didn't mention with the graphing calculators, if you just do negative 1 squared on a Texas Instruments calculator, it's going to tell you the answer is a negative 1, where negative 1 times itself is a positive 1. So make sure putting a negative to an even power, you put it in parentheses. It's just a kind of a fluke with how the calculator does the math. So that part there becomes a 1, and probably should quit doing the color coding. It's going to drive us all a little bit crazy, but we end up with a f of 1. And now we are doing our f functions. We jump up here to x plus 5, and that's going to be 1 replaces my x plus 5. So final answer is 6. A couple more examples doing the same thing. So I rewrote my two equations up here at the top. And we start with the g again, that's on my inside. So g of 4 becomes 4 squared, because my g function is saying square whatever that number is. And then we're going to do f of that, which then this becomes f of 16, which now we shoot up to our f function. That gives us 16, replaces my variable, plus 5. For an answer of 21. And jump down here to this f of g of 8. So we start out with the g function again. So that becomes, you look up here, we put 8 in for x, so that's how I get my x, or my 8 squared. And then 8 squared is 64, so I have f of 64. Which then I jump up to my f function, because it's f of 64. Replace the x with 64, gives me a 64 plus 5 for a total of 69. Alright, one final example on this page at least. Here we're starting with the f function, so we just do them in the other order. That I go up here and I put my 8 in for x in the f equation, so I get an 8 plus 5. Normally I'm sure most people would just write 13 there, but now I have g of that, so that becomes g of 13. Which then, now we're looking at our g function, so we look over here and we replace the x with 13, so it gives us 13 squared, or 169 for that one. All right, we're almost to the end of this section. Now I have g of f of x. So it's only changing it slightly now that we have this f of x. And for that one there, when we don't have a number in there, that tends to throw some people, but it's kind of like looking at our f equation. I guess I have to scroll up for that. We have this f equation, and when we just have f of x, I guess there's two ways to look at it. One way is to say, where I have f of x on that page, well, you could just say, well, f of x equals this, so then I take x plus 5 and put it in for f of x. That's probably the easiest way to see it. Some people, that just really doesn't seem to work in their head. So for them, what I've told them is kind of look at it this way. Before, we took whatever was in the parentheses and we replaced the variable with it. So here we have an x, so you just replace this x with itself, which gives you x plus 5. That seems to work for some people's brains. But either way, we end up with this here, that we now have g of x plus 5. And now if we look for our g function was take whatever this is and square it. So then that would give us x plus 5 squared. And if you've mastered the binomial square theorem, it'll save you a lot of time. You just jump down here and say, well, that's going to be x squared plus 10x plus 25. You smile and you're done. If you don't remember that, then it's similar to that beastly example we had at the beginning. Not quite as bad, but it's x plus 5 times itself. You can't just say x squared times or plus 5 squared. Then we have to FOIL, giving us x squared for the outside. Then we do, I'm sorry, for the first. Then we do the outside is plus 5x. Then we do the inside, another plus 5x. Then we do the last, positive 5 times positive 5 is positive 25. Then you could take and combine these two together to get the 10x. All right, very last thing, because it does show up, that when we have this f of g of x, another way that you could write it is just f is the composite of g of x, would be how they'd write it. It's a little open circle, so it's not multiplication. That's the exact same thing as f of g of x. And what I encourage some people to do, if that's confusing them when they get to a quiz, is just take that and just put parentheses right through the problem and go from there. That's all I have for section 1.